Lesson: Types of Cyber Threats. Cybersecurity is an indispensable component of modern information technology infrastructure, safeguarding data, systems, and networks from diverse cyber threats. As digital transformation accelerates, the sophistication and frequency of cyber threats have concurrently evolved, posing significant risks to individuals, organizations, and nations. Understanding the various types of cyber threats is crucial for developing robust security frameworks and employing effective countermeasures. Malware, an abbreviation for malicious software, encompasses a broad category of harmful programs designed to damage, disrupt, or gain unauthorized access to computer systems. Common types of malware include viruses, worms, trojans, ransomware, and spyware. Each type operates differently, but shares a common goal of compromising the integrity, confidentiality, or availability of data. For example, ransomware encrypts a victim's files, demanding a ransom payment for decryption. The WannaCry ransomware attack in 2017 infected over 230,000 computers across 150 countries, causing substantial financial and operational damage. Malware can propagate through various vectors, including email attachments, infected websites, and removable media, necessitating comprehensive security strategies to detect and mitigate such threats. Phishing attacks exploit human psychology to deceive individuals into divulging sensitive information, such as usernames, passwords, and credit card details. These attacks often involve fraudulent emails or websites that mimic legitimate entities, tricking recipients into revealing confidential data. According to the Anti-Phishing Working Group, phishing attacks increased by 65% in 2020, underscoring the growing sophistication and prevalence of this threat. Spear phishing, a targeted variant of phishing, aims at specific individuals or organizations, often using personalized content to enhance credibility. The successful phishing attack on the Democratic National Committee in 2016 exemplifies the potential impact of such threats, leading to significant political and reputational damage. Mitigating phishing attacks requires a combination of technical defenses, such as email filtering and domain authentication, and user education to recognize and respond to suspicious communications. Denial of service and distributed denial of service attacks aim to overwhelm a target system or network with excessive traffic, rendering it unavailable to legitimate users. DOS attacks typically originate from a single source, while DDoS attacks leverage multiple compromised systems, often forming a botnet, to flood the target with traffic. The magnitude of DDoS attacks has escalated in recent years, with the largest recorded attack peaking at 2.3 terabits per second in 2020. These attacks can disrupt critical services, causing financial losses and damaging an organization's reputation. Effective mitigation strategies include deploying traffic filtering and rate limiting, as well as employing DDoS protection services to absorb and deflect malicious traffic. Man-in-the-middle attacks involve an adversary intercepting and potentially altering communication between two parties without their knowledge. This type of attack can compromise the confidentiality and integrity of sensitive information exchanged over insecure networks. For instance, an attacker on a public Wi-Fi network could intercept login credentials or financial data transmitted by users. Secure communication protocols, such as HTTPS and VPNs, are essential for protecting against MITRE attacks. Despite these measures, vulnerabilities in protocol implementations or user behavior, such as ignoring security warnings, can still be exploited by attackers. Advanced persistent threats represent a sophisticated and prolonged form of cyber attack, typically orchestrated by nation-states or well-funded adversaries. APTs aim to establish a persistent presence within a target network, enabling long-term data exfiltration or sabotage. These attacks often employ a combination of techniques, including social engineering, zero-day vulnerabilities, and custom malware, to infiltrate and maintain access to the target environment. The Stuxnet worm, discovered in 2010, is a notable example of an APT designed to disrupt Iran's nuclear program by targeting industrial control systems. Defending against APTs requires a multi-layered approach, encompassing network segmentation, continuous monitoring, and threat intelligence to detect and respond to anomalous activities. Insider threats arise from individuals within an organization who intentionally or unintentionally compromise security. Insiders may include current or former employees, contractors, or business partners with legitimate access to systems and data. These threats can manifest as data theft, sabotage, or unintentional disclosure of sensitive information. A 2020 report by the Panama Institute found that insider threats have increased by 47% over the past 2 years, with the average cost of an insider-caused incident reaching $11.45 million. Mitigating insider threats involves implementing strict access controls, conducting regular security training, and monitoring user activities for signs of malicious or negligent behavior. Supply chain attacks target the interconnected network of suppliers, vendors, and service providers to compromise a primary target. These attacks exploit the trust and dependencies within the supply chain, often infiltrating less secure components to gain access to the final target. The SolarWinds hack in 2020, attributed to a nation-state actor, exemplifies the devastating potential of supply chain attacks. By compromising the software update mechanism of SolarWinds' Orion platform, the attackers infiltrated numerous high-profile organizations, including government agencies and Fortune 500 companies. Strengthening supply chain security requires rigorous vetting of third-party vendors, implementing security standards across the supply chain, and continuously monitoring for signs of compromise. Social engineering attacks manipulate human behavior to bypass technical security measures. These attacks exploit cognitive biases and social norms, employing tactics such as pretexting, baiting, and tailgating to deceive individuals into performing actions that compromise security. For example, an attacker might pose as a technical support representative to trick an employee into revealing their login credentials. The effectiveness of social engineering attacks lies in their ability to exploit the human element, which is often the weakest link in the security chain. Enhancing security awareness and fostering a culture of skepticism can significantly reduce the success rate of social engineering attacks. Cryptojacking involves the unauthorized use of computational resources to mine cryptocurrency. Attackers leverage malware or compromised websites to hijack the processing power of victim systems, often without the user's knowledge. The rise of cryptocurrencies has fueled the proliferation of cryptojacking, as it provides a lucrative avenue for attackers to generate revenue. According to a report by McAfee, cryptojacking incidents increased by 29% in the first quarter of 2020. The impact on victims includes degraded system performance, increased energy consumption, and potential hardware damage. Detecting and mitigating cryptojacking requires monitoring for unusual CPU usage, deploying anti-malware solutions, and applying software patches to address vulnerabilities. Understanding these diverse cyber threats is essential for developing robust cybersecurity strategies. Each type of threat presents unique challenges, necessitating a comprehensive and adaptive approach to defense. By leveraging advanced technologies such as artificial intelligence and machine learning, cybersecurity professionals can enhance threat detection, response, and resilience. Furthermore, fostering a security-conscious culture and maintaining vigilance through continuous education and training are critical components in the ongoing battle against cyber threats. As the threat landscape continues to evolve, staying informed and proactive will be paramount in safeguarding digital assets and ensuring the integrity and security of information systems.